Today we're going to discuss the transport of cholesterol in the body. So the transport of cholesterol is facilitated by your lipoproteins. In the body, we have different types of lipoproteins, primarily your chylomicrons, your VLDL, IDL, LDL. So VLDL stands for very low density lipoprotein, intermediate density lipoprotein, and low density lipoprotein. And we also have your HDL, or your high density lipoprotein. So before we go into the details of the following, let's first discuss the general structure of your lipoproteins. So your lipoproteins are spherical in nature with a lipophilic core and a hydrophilic spherical outer capsule. So hydrophilic outer compartment. Now, the lipophilic core contains your triglycerides, your cholesterol esters. Whereas your hydrophilic outer component contains your phospholipids, your apoproteins, and free cholesterol. Now, the free cholesterol that can be found in the outer surface helps in stabilize and maintain its shape of your lipoproteins. Now, the apoproteins, okay, aside from increasing hydrophilicity, they are also responsible for binding to receptors. Your lipoproteins enter the bloodstream and reach the tissues where the contents are utilized. So for example, your triglycerides are converted into free fatty acid for fuel metabolism, and your cholesterol are utilized for the biosynthesis of membrane, as well as your steroidal hormones and your vitamin D. So let's first discuss your chylomicrons. Chylomicrons are the transport lipoproteins that are responsible for the transport of lipids and cholesterol from the diet into the bloodstream, and they produce chylomicron remnants. They are the largest of the lipoproteins and they are the least dense. So, mas marami yung lipid component nila versus that of the protein component. And there are apoproteins that are found into the surface of chylomicrons, and these include ApoB48, ApoC2, and your ApoE. Now, your ApoC2 is responsible for the activation of your lipoprotein lipase that can be found onto the surface of the capillaries near the adipose tissue, your cardiac muscle, your smooth muscle, and your mammary tissue. And they are responsible for the release of your fatty acids from the core triacylglyceride. Now, the lipoprotein E is responsible for binding to receptors of liver cells. So, they facilitate or they are able to recognize yung nare-recognize yung chylomicrons ng liver cells because of the apolipoprotein E na present dun sa surface. And kaya sila na endocytosed. So, kinukuha yung mga remnants ng liver cells. Now, we also have your very low density lipoprotein, which gives rise to intermediate density lipoproteins and your low density lipoproteins after nilang mawalan ng triacylglycerides or pag nababawasan yung triacylglycerides ng VLDL, yun na, it will give rise to intermediate density lipoprotein. Tas kapag ito na bawasan ulit ng triacylglycerides, ito naman yung low density lipoprotein yung napoproduce. Now, if the intake of fatty acid is greater than the immediate fuel requirement of the liver, yung fatty acids ay nako-convert into triacylglycerides and then na i-incorporate na sila into your VLDL alongside with your free and esterified cholesterol, your phospholipids, and apoproteins. Now, in the liver, so ito yung pathway ng endogenous na lipids. Yung kanina, yung chylomicrons, ito yung sa diet. Ito naman, yung VLDL, sila yung transport ng endogenous lipids. Now, they are produced in the liver and then it will eventually be transported into the blood and then into the tissues such as your smooth muscles, your cardiac muscle, and your adipose tissue, as well as your mammary tissue. Now, 50% of the VLDL, 50% niyan ay na binabalik sa liver, no, through endocytosis, and the remaining 50% is converted into your intermediate density lipoprotein and eventually to your low density lipoprotein. Now, 60% ng low density lipoprotein ay binabalik mo ulit sa liver. So, nare-recognize nga yung apolipoprotein E. Okay? And 40% is being transported into the extra hepatic tissues. And ito naman, nare-recognize sila ng ApoB100 receptors. Now, yung transport ng LDL doon sa loob ng tissues ay receptor mediated. So, ibig sabihin, nasa-saturate mo, no, yung receptor. So, meron kang saturation of receptors. So, ibig sabihin, kung ano man yung hindi na kayang kabitan ng receptor, yung mga excess mo na LDL, they are taken up, okay, by your macrophages. The uptake of macrophages ng LDL is non-specific. And this one is the explanation or ng pathogenesis ng atherosclerosis. Ayan. Moving forward with high-density lipoproteins. Ayan. So, sila naman, meron silang apoproteins na ApoA1, ApoA2, ApoC1, and ApoC2. Okay? Now, the synthesis of HDL may happen in three ways. So, number one is the production of nascent HDL in the liver and intestines. They contain low triacylglycerides and also low esters of cholesterol. Number two
they can also be produced from budding, okay, from your chylomicrons and VLDL. So the remnants of your chylomicrons and VLDL can accumulate more lipids. And number 3, they can be produced from free ApoA1, which acquire more cholesterol and phospholipids from other lipoproteins and cell membranes. Now, itong nascent na HDL, okay, upon maturation, they accumulate phospholipids and cholesterol from cells. So, yung increase ng cholesterol ester helps in the production ng spherical shape. The transfer of lipids towards the nascent HDL is non-enzymatic.
The high-density lipoprotein is commonly known as your good cholesterol. Now, your HDL is responsible for a process known as your reverse cholesterol transport. This process is mediated by ABC1, ATP binding cassette 1, which utilizes ATP hydrolysis to transfer the cholesterol from the inner membrane towards the outer membrane. Now, once na nandun na siya sa outer membrane, no? So, halimbawa, ito yung inyong cell membrane, tapos nandito yung cholesterol. Ita-transport yan dito sa outer leaflet. Tapos, kapag meron ka na nung HDL, ito, kukunin yan, yung cholesterol na yan. Kukunin yan ng HDL. Tapos, itatrap niya. Okay? Now, the trapping mechanism is because of the enzyme LCAT, that's your lecithin, cholesterol, acyltransferase. Okay? So, ang nangyayari is that yung fatty acid from the 2 position of your lecithin in the phospholipid shell, di ba nandyan, meron ka mga phospholipids dyan sa labas, meron ka dyang lecithin, tapos, ngayon, since that's a phospholipid, meron kang fatty acid na component, di ba? Ngayon, ita-transfer ngayon itong enzyme na ito, yung fatty acid component dun sa 3-hydroxyl group ng cholesterol. Kumbaga, nagkakaroon ng esterification. So, ang ending na product mo ay cholesterol ester. Tapos, kapag ka na-convert na yan sa cholesterol ester, mapupunta to dun sa core na lipophilic. Tapos, hindi na siya ma-return back doon sa cell. So, that's one way of trapping your cholesterol dun sa loob ng HDL. Now, let's discuss what are the fates of your high-density lipoprotein. Now, we have the receptor na nakaka-recognize sa kanya. So, number 1, okay, is the uptake by scavenger receptor SRB1. Okay. Now, your SRB1 is present in many cells and actually, hindi talaga uptake na endocytosis yung nangyayari, no? So, for example, ito yung cell mo. So, dyan yung SRB1. So, once na ma-recognize niya yung high-density lipoprotein, yung cholesterol at saka cholesterol esters, cholesterol and cholesterol esters ay pumapasok doon sa cell, and ayun na, nawawala yung cholesterol and cholesterol ester component ng high density lipoprotein. Now your SRB1 is upregulated sa cells na kailangan ng cholesterol for biosynthetic purposes, like for example yung paggawa ng hormones or vitamin D. Ayan. Or kapag kailangan mo nung paggawa ng membrane. Okay? So, that's one of the fates, no? Pangalawa, yung HDL mo can have interaction with your other lipoproteins. Kung naalala nyo, no, nung previous discussions natin, so your HDL transfers the ApoE component as well as the ApoC2 into the chylomicrons and VLDL. Ayan. Now, after digestion, ayan, yung ApoE tsaka yung ApoC2, ibabalik naman ngayon, no, doon sa HDL. Number 3, we have the CETP. Okay, so cholesterol ester transfer protein. Now, this one, CETP, is responsible for the transfer of cholesterol. Diba? So, if this is your HDL, ayan. So, yung cholesterol, ita-transfer niya papunta ng VLDL or VLDL remnants. In return, yung triglycerides naman na component ng VLDL or VLDL remnants, ayan, ibabalik naman or ipupunta mo doon sa HDL. So, ito yung trabaho ng cholesterol ester transfer protein. Now, we're going to discuss some lipoprotein receptors. Now, in the cell membrane, that's where so yung una nating pag-uusapan is the LDL receptor. So, nandito sila sa may cell membrane. Okay? So, may mga parang invaginations doon sa cell membrane. So, doon natin makikita yung mga LDL receptors na yan. So, around the invagination, we have your clathrins. So, these are proteins which help in the process of endocytosis. Now, your LDL receptors are able to recognize two proteins. So, yung una is your ApoB100 and yung isa is your ApoE. So, once ma-recognize nila yan, magkakaroon ng endocytosis. So, ayan. So, ito yung LDL. And then, it will combine with the lysosomes. And then, madedegrade na yung mga cholesterol components na nandito sa loob ng LDL, producing your cholesterol. Now, itong cholesterol, i-esterify siya agad by your ACAT na enzyme. Important to kasi ayaw mo na masyadong mataas yung levels ng cholesterol, which is detrimental to the cell membrane. Now, another receptor is the LDL receptor related protein. This one naman has a broader specificity and they are able to recognize alpha macroglobulin and also tissue plasminogen activator and inhibitors. Specifically, they are able to recognize also ApoE and binds the remnants of chylomicrons and VLDL remnants. Ito, makikita to sa liver, sa brain, and as well as in the placenta. Bali, yung synthesis nito is not affected or is not significantly affected by the levels of cholesterol. Unlike in your LDL receptors, so yung levels ng cholesterol, pag mababa yung cholesterol, intracellularly, nag-i-increase yung LDL receptor synthesis. Kumbaga na-upregulate siya. Ito naman, yung LDL receptor-related protein, affected naman yan by increase in insulin levels. So, kapag mataas yung insulin, mataas din itong levels ng LDL receptor-related protein. Increase in upregulation. Pangatlo is the macrophage scavenger receptor. So this includes your SRA1 and SRA2. Okay? So bali, your macrophage scavenger receptor is not subject to downregulation. And ang nare-recognize nila ay yung oxidized na LDL. So, the oxidation of your low-density lipoprotein may be due to your hydrogen peroxide, your radicals, and your nitric oxide. Now, yung vitamins na C, E, at saka yung carotenoids may have some protective effect. So, pinipigilan nila yung pag-oxidize ng LDL.